factors. The concept of factors is very significant to children. The concept of ACF help in understanding more other important concepts in mathematics. That's why we have to build on this very well. We have to look. It helps them to understand concepts such as factorization, helps them to understand things like permutation and combination. So the concept of factors have to be carefully explained. And it's one important topic that we'll have to look at. So today we'll be talking about factors as well. And over the time, we've looked at various methods by which we could find the factors of numbers. We looked at using the products. We also look at just using the factor tree. And today we'll look at the division method. And in the division method, when we have set of numbers, let's say, find the highest common factor of 18 and 24. What we'll have to do is this. So 18 here and then 24 here. We want to find numbers that can divide them. So I start with 2. And I know 2 can divide 18. So 2 into 18. That's 9. 2 into 24. We have 12. And I go with another number as well. So any number that has been able to divide both of them, I put a star by it just to note it down. And I come to this 2. I use 2 here as well. 2 is not able to divide 9. 2 is not a factor of 9, so I drop the 9 back. And then 2 into 12, that would be 6. 6. Alright, I use another factor as well, 2. But here 2 still can't divide 9. So I quickly drop the 9 as it is. And I know that 2 is able to divide 6 by 3. So I wouldn't have to put any asterisks behind this 2 since it was not able to divide both of them. Okay, I go with 3 as well, since 3 is the only number that can divide this 2. So 3 into 9, 3 times, and then 3 into 3, just 1. And you can also see that this 3 has been able to divide the 2 numbers. Alright. And then I come with 3 again. 3 is able to go into this one. Just 1. And then at whatever point I reach the least factor of any 2 numbers, which is the least common factor of any 2 numbers, which is 1, I stop. The factors then, the highest common factor is then going to be, the highest common factor is then going to be the 2 numbers that I have. So these 2 numbers, so that would be 2 times 3 is equal to 6. So therefore, the highest common factor of 18 and 24 is equal to 6. So this was one of the methods to do. Alright. When we also look at factors, we realize that we don't learn this concept just for fun. It relates to so many things around us. We said factors are various ways that we group things. Factors are various ways that we can share things. Therefore, there are some problems that we see in our everyday life that would demand that we group or share things. So in a typical word problem, there are some words you have to be on the lookout for. So let me put some of those words down. So word problems or factor word problems. Factor word problems. And there are expressions you see, you know that when you see the sum of, you know you are looking at addition. When you see the difference, you are looking at subtraction. There are words that you see in mathematical problems, that also informed me that this question also involves factors. So we'll talk about identifying the keywords. Identifying the keywords. So what keywords do we see to know that this question is about factors? You hear words like pieces. Pieces. So you see something like a rod is cut into 3 or 4 pieces. You hear things like equal parts. Equal parts. So it's shared into 4 equal parts. So already when we talk about factors in our introduction, we said that factors are ways we can group things. Or factors, a factor is a number that can divide a product equally without a remainder. That's a factor. So when you hear equal parts, you should know that that question is suggestive of factors. Find the ACF or maybe just the factors. So you see words like equal parts, you see words like no remainder. No remainder. And you could also see words such as without waste. Very cardinal here. Without waste. Without waste. If it's going to be done in equal parts, without waste. If something is shared in equal parts, or evenly, we are trying to make sure we don't entertain waste. Alright, you will see no leftover, no leftover, no leftover. And you will also see some other words like something is being splitted, something is being grouped, something is being divided. So splitted, grouped, splitted, grouped, okay, splitted, grouped, and then you see words like divided, also suggestive of a factor word problem. So let's look at a few questions here. Alright, Kwame has, let's look at a question like this. So Kwame has two bowls full of two different fruits, oranges and apples. He wants to share them into groups for his friends. If that Kwame can make. Alright. Okay, now, so this is a typical question involving factors. So Kwame has two bowls full of two different fruits, oranges and apples. He wants to share them into groups for his friends. What is the greatest number of gift packs? Probably he wants to give the fruits as gifts. So gift packs Kwame can make using all the fruits. So let's see how we can go about it. Immediately we see this word share. And then what word suggests this? So share. Share, okay, so let's put this here, share. When we see words like share, we see words like into groups. Groups. We know that we are looking at factors. Now, So he has, so the question says that there are 36 apples and 24 oranges. So quickly we identify the words group and share. So just while we are looking at factors, there are 36 apples and then 24 oranges. So let's go with solution. Now for the apples and then the oranges. Okay, so apples can go this way. We can have one group of 36, can have two groups of 18, three groups of 9, four groups, can have four groups of, three groups of 12, sorry, three groups of 12, four groups of 9, 6, and then 6 groups of 6. So one group of 36, two groups of 18, three groups of 12, four groups of 9, 6 groups of 36. And we said that whenever there is this reverse, a number repeats itself like this, it's possible that the other groups can be formed in the opposite. So we just have to go this way. That would be 9 groups of 4, 12 groups of 3, 18 groups of 2, and then 36 groups of 1. All will give us 36. Now for the oranges, we could have it this way. So one group, so 24. So one group of 24, two groups of 12, three groups of 8, four groups of 6, and then 6 groups of 4. And we also said that when a number has this interchange like this, the other factors or the other groups are going to be in this part. So you could go the reverse. That would be 8 groups of, so 8 groups of 3. Yeah, 8 groups of 3, 12 groups of 2, and then 24 groups of 1. All this will give us 36. Now, having noticed this, so groups against contact, let's put this here. Groups against, so groups against content or number of fruits. So groups against number of fruits. Okay. All right. So how many of the various groupings do they have in common? So the apples, we're able to form 2 groups with apples, and we're also able to form 2 groups with oranges. We're able to form 3 groups with apples and then 3 groups with oranges. We're able to form 4 groups with apples and then the same for oranges. 6 groups with apples and then 6 groups for oranges. We're also able to form 12 groups for apples and then 12 groups for oranges. We're also able to form, okay, so that's the highest that could be formed. Now, we are trying to ask for the greatest number of gift packs. So the gift packs are obviously going to be in groups. So the greatest number of groups that he can form with both of this. So let's try for 3. If he should form 3 groups, we expect something like this. So 1, 2, 3. And then he's going to have 12 apples in each 3 groups. 12, 12, 12. And he's going to have 8 oranges. 8, 8, and then 8. 8 oranges in each of the 3 groups. Now, however, this is not, you could form other bigger ones. And from the question from what we've written so far, we can realize that the biggest group it could form, both of them can form, is 12 groups. So we'd have something like this. Very fast. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it's going to have 3 apples in each group. That would be 3 apples. So 3, 3, 3, 3, 3. Okay. And then it's going to have 2 oranges in each group. That would be like this. 2, 2, 2, 2, 2, 2, 2, and then 2. And when you add everything, you realize that he will get 36. Or he will get his 60 in total. Very good. Okay, so we can therefore say, so let's put it here. Therefore, the greatest number of gift packs is 12. So 12 gift packs. So see, beautiful gift packs. Yeah, beautiful gift packs full of oranges and apples. Yeah, that's how simple it is.